Beneath the thin layer of time we call history lies a silence deeper than any library. It is the quiet of stone, of oceans, of a planet that has been turning for billions of years before we ever opened our eyes. We walk across its surface as if it were a stage built only for us, measuring our past in monuments and names. But the Earth measures differently. It writes its stories in pressure and heat, in sediments and tides, and most of those pages have already been turned, erased, or buried far beyond our reach. Sometimes, though, the thought lingers, what if we are not the first to think, to build, to change the face of the world in ways that could be measured long after we are gone? If something came before us, would we even know? Or would time have folded its memory so deeply into the planet that it looks like nothing more than ordinary rock? This is not a question of belief or certainty, but of possibility, a quiet wondering that begins when you realise how little we truly see of the Earth's past. Tonight, we will follow that wondering, listening for the faintest echoes in stone and sea. You're watching Arcane Skies. If the journey pulls you in, consider liking, subscribing, and letting us know in the comments where and at what time you're joining us. The first step in chasing a question this large is learning to see the world in scales of time far beyond the span of our own lives. We are used to years, decades, at most centuries, as if the human story is the measure by which all else should be judged. But when you stand on the edge of a canyon and look at the layers of stone stacked one atop the other, you begin to sense a clock that has been running far longer than any civilization. Each layer is a page laid down over millions of years, written not in ink but in minerals, each grain carrying the memory of an ancient shore, a vanished forest, or a world drowned beneath shallow seas. In this clock, the entire history of agriculture is barely a breath, the rise and fall of empires nothing more than the flicker of a second hand. To imagine that something could have come before us is to accept that the Earth is not a fixed backdrop, but a restless stage. Continents drift like slow rafts on molten seas. Mountains rise only to be worn to dust. Oceans open and close over spans so vast they make the oldest human artifacts look new. In this constant reshaping, the evidence of the past does not simply fade, it is consumed. Heat and pressure do not care for the intentions of builders or the pride of nations. Stone is ground into sand, sand into silt, silt into rock again, and the cycle repeats until the original form is unrecognisable. It is no wonder that the earliest chapters of our planet's story are blank to us. They have been written and erased many times over, leaving only fragments that survive by accident. Even fossils, the most enduring souvenirs of life, are rare. They require a perfect balance of chance, or the right burial, the right mineralization, the right protection from erosion. And even then, most will eventually vanish. For every skeleton in a museum, there are millions that left no trace at all. If this is true for bones and shells, what hope would there be for the works of an intelligent hand? A city's tallest towers might stand for centuries against wind and rain, but give them 10,000 years and they crumble. Give them 1,000,000 and they are gone entirely. No streets, no walls, not even dust that could be recognised as having once been a home. Only stone, bare and unyielding, would remain, perhaps with some faint and unremarkable chemical irregularity deep beneath its surface. This is why the idea of a civilization before ours is not dismissed out of hand by some scientists. It is not because there is proof, but because they understand the ruthless efficiency of geological time. They know that absence of evidence is not the same as evidence of absence, especially on a planet that recycles itself from the crust inward. They call this thought experiment the Silurian hypothesis, not a claim that there were others before us, but a way to ask whether we would even notice if there had been. The unsettling part is how often the answer leans toward no. The traces we imagine, monuments, machines, tools, would almost certainly be gone. What might remain would be subtle, a layer of rock with unusual concentrations of certain metals, a shift in the balance of carbon isotopes that cannot be explained by volcanoes or meteor strikes. Perhaps synthetic molecules buried so deep they lie beyond the reach of erosion. The Earth's surface, the part we walk on, is a deceptively thin veneer over a far more ancient body. Most of it is young compared to the planet itself, resurfaced over and over by the slow movement of tectonic plates. Even the ocean floors, vast as they are, rarely preserve anything older than 200 million years, because the crust beneath them is constantly being pushed down into the mantle and remade. That means if a civilization had thrived 500 million years ago, the sea floor it built upon would now be gone entirely, melted and reborn in a form unrecognizable. On land, the odds are only slightly better. Rocks billions of years old do exist, but they are rare and often so altered by heat and pressure that the fine details of their history have been erased. To grasp the scale of this erasure, picture our own world abandoned. Within a century, plants and animals would reclaim our cities. Within 1,000 years, most structures would have collapsed, their remnants buried or washed away. 10,000 years, and even the most durable works of concrete and steel would be gone, ground into the soil or carried to the sea. 1,000,000 years, and the last traces would be folded into the landscape so completely that only a trained eye could detect them, and even then only as oddities. Given 10 million years, not even that. The continents might have shifted, the land itself swallowed by mountains or seas, leaving nothing to show it had ever been different. This is not a thought experiment designed to encourage fantasy. It is instead a mirror held up to our own time. We can already see the kinds of signals we will leave behind. Our metals, our plastics, our altered atmosphere, and they are not as obvious as we might think. A geologist millions of years from now might not know our names, but they could detect the strange thin line of chemical difference we have pressed into the rock. They might find unusual pulses of copper, aluminum, or rare earth elements scattered across the globe, not matching any known natural pattern. They might see the carbon signatures of a brief but intense industrial age. They might find traces of polymers that no natural process could have produced, but these would be clues only if they knew to look for them. Without context, they might be dismissed as anomalies, quirks of geology, nothing more. And so the question persists: if something like us had risen and fallen long before our own species appeared, would we have any chance of knowing? If it lasted for only a few thousand years, as ours has so far, in a span of millions, or tens of millions, how would it leave a mark strong enough to survive the churn of the earth? Perhaps it wouldn't. Perhaps we have already walked over the last of its traces, not recognizing them for what they were. Perhaps they have been drilled through in search of oil, or crushed beneath the foundations of our own cities. Or perhaps they lie too deep, too far beyond our reach, sealed away in places we will never see. And yet the absence of certainty is also the source of possibility. The planet's history is full of surprises, events we did not suspect until we learned to read the language of stones. Mass extinctions, sudden climate shifts, asteroid impacts, none of these were obvious until their subtle marks were found in the rock. If such profound events can be hidden until we learn how to see them, then perhaps the same could be true of a forgotten chapter written by hands we will never meet. The search for such a chapter is not about proving it happened. It is about expanding our understanding of what might be possible on a world as old and restless as our own. If we are to imagine the possibility of something before us, we must first step outside the comforting straight line we draw from our own beginnings to the present. Human history is often told as a story with a clear starting point, a migration here, a first tool there. But the Earth story is more like a looping, folded script where pages are torn out, rewritten, and sometimes layered over each other until the original words are unreadable. Deep time is not a steady progression, but a tide, pulling life forward, then dragging it back, erasing shorelines and rebuilding them elsewhere. To move within that timescale is to accept that memory, both human and planetary, is fragile. The forces that shape this planet work constantly, whether or not we notice them. Wind scours the face of mountains. Rain cuts canyons through rock. Glaciers grind valleys into smooth bowls of stone. Rivers shift and twist, flooding old banks and abandoning them for new paths. Each change seems small in the moment, but given enough time, they consume everything. Even what we call permanence, the hardest granite, the tallest cliffs, become sand under their patient work. And beneath all of this, the ground itself moves. Tectonic plates drift at the speed of fingernail growth, but over millions of years, they can drag entire continents, halfway around the globe, splintering coasts and shoving mountain ranges skyward before wearing them back down again. It is in this endless transformation that the challenge lies. Imagine a civilization that thrived 50 million years ago. It might have risen along the edge of a sea that no longer exists, its harbours swallowed by land or plunged into deep ocean trenches. Its inland cities might have stood where there is now only desert, or beneath ice, or under a forest so thick no sunlight reaches the ground. Over millions of years, sediment could bury its remains thousands of meters deep. Volcanic eruptions might entomb what the sediment missed, and in places where the crust is recycled, its very foundations could be drawn down into the mantle and transformed into molten rock. In such a cycle, survival of any direct evidence becomes almost impossible. This is why geologists do not look for ancient cities when they think about the Silurian hypothesis. Instead, they look for signals, the quiet chemical kind, that do not care about form or shape. The asteroid that ended the age of dinosaurs left no cities, no artifacts, only a layer of iridium dust thin enough to fit between the pages of a book, yet spread across the entire planet. That dust told a story that had been hidden for 66 million years. If an industrial civilization had existed in some remote age, it might have left a different kind of layer, an unusual ratio of carbon isotopes from rapid burning of fuels, trace metals in concentrations nature does not produce, or microscopic remnants of synthetic materials locked into stone. These clues would not look like anything built. They would not even look remarkable unless you already knew how to read them. Our own age offers an example of how faint these signals might be. In just 2 centuries, human industry has altered the atmosphere's chemistry enough to be measurable anywhere on Earth. We have scattered metals across the planet in patterns unlike anything found in natural geology. We have created plastics that, while fragile in daily life, could persist in buried sediments far longer than our cities will stand. And yet, in the grand scale of geological time, these marks will be small, a thin layer, no more than a whisper in the rock, vulnerable to being lost if the crust that holds it is ever destroyed or deeply buried. This is why, in searching for something older, the ocean floor becomes so important. Most of it is younger than 200 million years because of constant recycling, but within that window, it holds one of the most continuous records on the planet. Sediment falls slowly from above, preserving chemical changes like lines in a ledger. Deep sea cores reveal shifts in climate, mass extinctions, and even ancient volcanic events with extraordinary precision. If an earlier civilization had left a measurable trace, there is a chance it might still be recorded there. Not as ruins, but as an anomaly in chemistry or composition. The problem, of course, is that we have only sampled a tiny fraction of the ocean floor, drilling in scattered locations that barely scratch the surface of the planet's largest archive. Even on land, the search faces similar limits. The oldest stable regions of crust, known as cratons, can preserve rocks billions of years old, but their surfaces have been altered by weathering, erosion, and pressure. If something once stood there, its imprint would be faint at best, tangled among signals from countless other geological and biological events. The deeper we dig, the more the story blurs, as if the words in an ancient manuscript have been smudged by time until only scattered letters remain. This is not a flaw of science, but a property of the Earth itself. It keeps nothing forever in its original form. Yet the fact that most of the record is missing does not mean there is nothing to find. Sometimes the most revealing clues are those that do not fit. An unexpected mineral concentration, a chemical ratio that resists easy explanation, a pattern of change that suggests an outside influence. These anomalies do not leap out as proof of a lost civilization. More often, they linger in the background, waiting for someone to connect them to a larger picture. The challenge is that natural processes can mimic these signals. Volcanoes can flood the atmosphere with carbon. Meteor impacts can scatter rare elements over wide areas. Even the evolution of new life forms can reshape the planet's chemistry. To separate the possible signature of an ancient intelligence from the noise of geology and biology is a puzzle without clear edges. And so the question remains a quiet one, its answer elusive. We may never know if something came before us because the conditions required for its traces to survive are so rare. But in asking, we are reminded of how brief our own presence is and how easily it could be folded into the stone. In that awareness, there is both humility and curiosity. Humility in recognizing that the earth does not revolve around our story, and curiosity in imagining what other stories might be buried beneath our feet. Every rock, every core sample, every layer of sediment becomes not just a record of what we know, but a potential page from a chapter we have yet to read. And if such a chapter exists, it may wait in silence for as long as it must, holding its secrets until we learn how to see them. To truly understand how something could vanish so completely, you have to imagine time not as a line stretching behind you, but as a tide that rises and falls, sweeping away entire worlds before pulling back to reveal new shores. When we stand on the surface and look around, we see permanence. We see mountains we assume have always been there, rivers that have always followed the same course, deserts that seem timeless in their stillness. But permanence on a human scale is a trick of perspective. The Earth has moved these features before, and it will do so again. Mountains are temporary wrinkles in the planet's skin. Rivers are threads that can be cut and rewoven. Deserts shift their borders with the patience of centuries, then erase themselves entirely in the span of millennia. It is in these transformations that erasure happens, not quickly, not in the dramatic sweep of a single cataclysm, but slowly, so slowly that the process is invisible until you measure it in millions of years. A city might stand for centuries before nature begins to reclaim it, vines threading through its walls, roofs collapsing under the weight of rain and snow. In 10,000 years, even its ruins would be hard to recognize. In 1,000,000, you would not find a single recognizable stone. By then, the land itself might have shifted. Hills might have risen where its streets once lay, or a shallow sea might cover what had once been a marketplace. The same processes that erase human works have been erasing the works of nature for billions of years. Forests that once covered half a continent have been buried, compressed, and transformed into coal seams. Coral reefs, hundreds of miles long, have risen from the sea, crumbled into sand, and been swept away by currents. Vast lakes have filled with silt, becoming grasslands or deserts. If these living landscapes can be erased so thoroughly, what hope would the works of an earlier civilization have? Even if they built in stone harder than anything we use, the pressures of burial, the heat of deep crustal layers, and the grinding motion of tectonic plates would eventually destroy them. There is also the matter of chance. For any trace of a civilization to survive deep time, it would have to be preserved in a rare and stable environment. The layer containing it would need to avoid subduction into the mantle, avoid erosion by wind and water, and avoid chemical alteration that might dissolve or transform its remains. It would need to remain accessible enough for us to one day reach it, but not so exposed that weathering destroys it before discovery. The odds of all these conditions aligning are small, but not impossible. After all, we have fossils from hundreds of millions of years ago that survived by sheer accident, creatures buried quickly in silt, plants sealed in amber, footprints preserved in volcanic ash. If life's delicate traces can last, perhaps so could some faint echo of industry. But industry, unlike biology, leaves a different kind of record. The byproducts of mining, smelting, and chemical processing can scatter across wide areas, seeping into soils and sediments. These signals are harder for nature to mimic perfectly. A sudden global spike in certain metals, for example, could be a sign of technological activity. The same is true for compounds that do not occur in nature, or that appear in combinations only possible through manufacturing. This is why the search for a pre-human civilization does not involve shovels and ruins so much as mass spectrometers and drill cores. The clues, if they exist, would be small enough to hide in the dust of a single rock layer. Even with our present technology, we are far from reading the whole record. Most of the Earth's crust is inaccessible to us. We drill only shallow holes compared to the depth of the planet's geological memory. We analyse only a fraction of the ocean floor, and our interpretations are limited by what we expect to find. If we discovered a strange anomaly in a rock layer 50 million years old, our first instinct would be to look for a natural explanation. This is the cautious and correct approach in science, but it also means that if the anomaly's true cause lay outside our experience, we might never recognize it. This is where humility becomes essential. We like to imagine that our current knowledge is enough to rule out entire categories of possibility. But Earth's history has proven again and again that it can surprise us. There was a time when we thought the continents were fixed in place. There was a time when we thought mass extinctions were impossible without human interference. There was a time when we did not know that giant impacts from space had reshaped life on this planet more than once. Each of these ideas was accepted only after evidence forced us to see past the assumptions we had built our understanding upon. The question of whether something like us came before is not one we can answer yet, but it is one we can keep open, not because we believe it did, but because we cannot yet prove it did not. In this openness lies the wonder of the search. It changes the way we look at the ground beneath our feet. A desert becomes a vault, storing layers of history beneath its shifting sands. A mountain range becomes a library, each exposed cliff a shelf of stone pages. The deep ocean floor becomes the planet's longest-running archive, built one thin layer at a time. And every one of these archives is incomplete. Pages are missing, chapters erased. The silence between the surviving records is vast, and it is in that silence that the imagination begins to work. For some, this imagination leads to elaborate stories, lost continents, sunken empires, forgotten gods. But the version that interests science is quieter, stripped of the details we cannot know. It is the version that asks not what they looked like or how they lived, but whether their existence is possible within the constraints of the Earth's history. If it is, then the next question is whether we could detect them. And if we could, the question after that is whether we have already seen the evidence without realizing it. Perhaps one day, a single drill core from the bottom of the Pacific will reveal a thin layer of unexplained metal concentrations, a spike of synthetic compounds, or a sudden brief shift in the carbon cycle. Perhaps the anomaly will at first seem like the product of volcanic activity, only to later resist every natural explanation. Perhaps then, and only then, will we begin to suspect that the story of life on Earth is not as linear as we once thought, or perhaps no such evidence will be found, and the question will remain unanswered, living on only as a thought experiment that taught us to see our own fragility more clearly. For now, the search is as much about ourselves as it is about the past. To imagine something before us is to imagine the same fate awaiting us, not in a single catastrophe, but in the slow, unrelenting work of time. One day, our tallest towers will vanish, our maps will mean nothing, and our presence will be reduced to a few faint signals in the stone. We too will be a possibility someone else may one day wonder about, a ghost in the geological record, silent and nearly invisible. And perhaps that is enough reason to keep asking the question. Because to ask it is to remember that we are temporary, but the Earth's memory, though imperfect, is long. When we think of the traces we might leave behind, it's tempting to picture something monumental, a skyline of skeletal towers, fossilized in place, roads etched into stone like veins, satellites falling back to Earth as strange metallic meteorites. But that is not how time works. Time strips away shapes first, then details, then the very structure of what was built, until all that remains is a change in the chemistry of the Earth itself. The memory of us, if it survives at all, will be dissolved into the stone, indistinguishable from the rest of the planet, unless someone knows exactly where and how to look. And if that is our fate, then it is likely the fate of anything that came before. We imagine an earlier civilization as something that would look familiar to us, cities with plazas, ports along coasts, art carved in stone, because that is what we know. But familiarity is a poor guide when the span between us and them could be tens of millions of years. The world they lived in may have been unrecognizable, its continents arranged in unfamiliar ways, its climate alien to us. Even the air might have held a different balance of gases. If they built, they might have done so with materials long gone from the surface, or with methods that left no direct evidence. Their industry might have run on resources we no longer see, their tools crafted from substances that decay quickly in open air. What would remain after so much time? Perhaps only the faintest anomalies, tiny interruptions in the patterns of stone, strange alignments in chemical ratios, scars in the sediment where the planet's natural rhythm was briefly broken. It is here that deserts, ice sheets, and the deep sea enter the story as more than just landscapes. They are the Earth's quiet archives, places where change happens slowly, where the world stores what it does not wish to destroy. The Sahara, for example, is more than a vast expanse of sand. Beneath it lie layers of rock and ancient seabeds, hidden for millions of years, undisturbed by rain or roots. In the dry air, fragile things can survive far longer than they should. Papyrus scrolls, wooden tools, even the faint impressions of human footprints. If such preservation can happen over a few thousand years, what might still be buried far deeper, sealed away from light and air for eons? The odds are slim, but not zero, and that sliver of possibility is enough to keep the question alive. Ice tells a similar story, though in a different language. Glaciers move slowly, but they preserve a record as they advance, capturing dust, pollen, ash, and traces of gases from the air. Cores drilled from Antarctic ice sheets can reveal snapshots of the planet's atmosphere going back hundreds of thousands of years. In ice older still, if it could be reached, there might be traces of something stranger. Not fossils, not ruins, but chemical fingerprints that do not match any natural process we know. These too would be hard to recognize without context. They might be dismissed as contamination or ignored entirely because they do not fit the expected pattern. The ocean, though, holds the deepest potential. Beneath miles of water, the seabed collects its history grain by grain, year after year, as particles drift down from above. In this dark, cold stillness, layers can remain undisturbed for millions of years. Drilled cores from these depths have revealed the aftermath of asteroid impacts, the rise and fall of ice ages, and the slow-breathing cycles of the Earth's climate. If an earlier civilization burned fuel, mined metals, or produced synthetic materials, some fraction of that activity could have settled here, preserved in the sediment. The challenge is not just finding it, but recognizing it for what it is. Recognition is where the difficulty sharpens. Natural processes can mimic industrial signatures in ways that confuse even trained eyes. A volcanic eruption can release metals into the environment. A shift in ocean currents can alter carbon ratios. Meteor impacts can scatter exotic minerals across the globe. These events, while rare, leave marks that are easy to mistake for the byproducts of life and technology. And the reverse is also true. Something artificial might be overlooked because it so closely resembles the output of a natural process. Without a clear trail of multiple consistent signals, the conclusion remains uncertain. And yet, uncertainty does not mean impossibility. It means the story is still unfolding, still open to new pages. Every year, new techniques allow scientists to see deeper into the record, measuring isotopes at scales once thought impossible, scanning landscapes for subtle patterns invisible to the human eye, recovering chemical traces from samples that seemed inert. As these tools sharpen, anomalies that once seemed meaningless may take on new significance. A spike of a particular metal in a layer of deep-sea sediment might be reinterpreted as the residue of mining. A sudden, brief change in carbon isotopes might be seen as evidence of an industrial pulse rather than a natural shift. In this way, the past can change without the past itself moving. Only our understanding of it does. We are in some ways still learning to listen to the Earth's language. Stones speak slowly, they do not shout, and they rarely tell a full story in one place. A cliff face may reveal 100,000 years in a few feet of rock, but those years are silent on what happened elsewhere. To piece together a planetary history, we have to gather fragments from everywhere: deserts, mountains, ocean floors, ice sheets, and arrange them like puzzle pieces that may never form a complete picture. Somewhere in those pieces could be the faint imprint of another intelligence, not enough to identify, perhaps not enough to prove beyond doubt, but enough to raise the possibility that we are not the first to think, to build, to leave a mark. If such a possibility exists, it is humbling. It means that our story is part of something larger, that the rise and fall of civilizations might be a recurring pattern rather than a singular event. It suggests that intelligence, like life itself, may emerge more than once given enough time and the right conditions. And it reminds us that even the greatest achievements are fragile in the face of deep time. For all our pride in our cities, our machines, our reach beyond our planet, the Earth will eventually fold us back into itself, as it has done with everything before. Whether or not we are alone in that fate, we cannot yet say. For now, the question is a whisper, carried in stone and sediment, in ice and sand. It is an echo from a past we cannot see and may never fully know. But it is there, waiting, not for belief, not for certainty, but for the moment when the tools and the patience align and we can read the page that has been hidden for millions of years. Until then, every step we take on this restless planet is over layers of history we barely understand, some written by nature alone, some perhaps by hands and minds long gone, all of it held in the deep and imperfect memory of the Earth. To stand at the edge of a desert, an ice field, or an ocean trench and think of them as archives rather than landscapes requires a kind of shift in the way we see the world. It is easy to think of history as something that exists above ground, in monuments, in ruins, in the visible traces of those who came before. But most of history, especially the kind that survives deep time, exists below our feet, locked away in places we rarely think to look. And yet, even when we do look, even when we drill into stone or sift through sediments, we must remember that these are incomplete records. They are not photographs of the past, but scattered notes in a language we are only beginning to learn to read. That incompleteness is what makes the question of an earlier civilization so difficult. If their story were written in towering structures of stone, perhaps we might still see them. But stone erodes, wind and rain grind it down, ice splits it apart, the heat of the Earth's interior warps it, and tectonic movement folds it into new mountains or drags it beneath the oceans. What once stood proud on the surface can be buried miles deep, transformed into something unrecognizable. Even the most enduring human works, the pyramids, the Great Wall, the monuments cut from solid rock, are only a few thousand years old. Set against millions, they would be swallowed whole. In a way, this is the most humbling truth. The Earth is not a museum. It does not preserve its artifacts for display. It is an artist that constantly paints over its own work, layering new scenes over the old, sometimes keeping fragments, but rarely the full image. The result is a planet where absence is as telling as presence, where the blank spaces between what we can see are as vast as the records we do possess. And it is in those blank spaces that a possibility can hide, untouched, for longer than any civilization could hope to endure. But possibility alone is not enough. To even begin to suspect that something once was, we need signals, not grand, visible structures, but quiet chemical or geological signatures. The problem is that such signatures must be strong enough to survive the erasures of time and subtle enough not to be erased by other natural events. This is why the Silurian hypothesis is so carefully framed. It does not claim there was anything before us. It asks whether we could recognize it if there had been. The answer depends on whether the byproducts of a civilization's existence could leave a mark deeper and more persistent than stone. One such mark might be a sudden change in atmospheric chemistry. Our own age is leaving one now. The carbon dioxide levels in the atmosphere are rising at a pace unmatched in natural history outside of catastrophic events. If locked into sediments, this signal could be read millions of years from now as a sharp spike in the carbon isotope record. Another possible marker is the sudden appearance of materials that nature does not produce on its own, certain alloys, plastics, or complex synthetic compounds. Even if they break down at the surface, fragments of them might be buried and preserved in deep ocean sediments. Over geological time, these fragments could become embedded in stone, sealed away until some future hand breaks the rock and analyzes it. Mining and metal use offer another kind of signature. The extraction and redistribution of elements like copper, lead, and rare earth metals creates patterns in the geological record that are difficult for natural processes to mimic. A global pulse of such metals in sediment layers, coinciding with other unusual changes, could be one of the few ways to detect the presence of an earlier industry. This is why some scientists look not for artifacts, but for anomalies, sudden departures from the baseline conditions of the Earth's history. These are the hints, the faint echoes that might survive when everything else is gone. Yet for all of these possibilities, the task of recognition is daunting. The Earth is vast, and we have examined only a fraction of its surface in detail. Most of the ocean floor, the largest and most stable archive, remains unexplored. Even on land, there are entire regions where the geology is too complex or too altered to yield clear answers. And when we do find anomalies, the most likely explanation is usually natural. Extraordinary claims demand extraordinary evidence, and in the absence of direct artifacts, the leap from unusual to artificial is difficult to justify. Still, the search changes how we see the present. It reminds us that we are leaving our own signals, small but measurable, in the deep record. Our metals, our plastics, our carbon, these are our fingerprints. One day, they will be the only surviving testimony of our existence, buried in stone that will outlast every building, every book, every name. And if this is true for us, it could have been true for others. There is a strange comfort in that symmetry. If we are not the first, then our story is part of a longer cycle, a rhythm that has played out more than once on this planet. Civilizations rise, change their world, leave their marks, and then fade into silence. The Earth carries their memory not in monuments, but in the chemistry of its bones. In this view, our place in history is neither central nor final. We are a chapter in a book that began long before us and will continue long after. And so the possibility remains, fragile but unbroken, held in the deep silence of the planet's archives. Somewhere, perhaps beneath a desert, beneath a mile of ice, or deep under the ocean floor, there could be a page we have not yet turned. It would not tell us names or stories. It would not give us faces or voices, but it could tell us one thing, that we were not the first to look at this world and think, to shape it with intention, to leave behind a signal strong enough to outlast our own disappearance. Until then, the search is as much about patience as it is about discovery. Every sample, every core, every analysis is a question asked of the Earth. Sometimes the answer is immediate. A fossil, a mineral deposit, a clear record of an ancient climate. More often, the answer is silence, or something so faint that it can be read in more than one way. But each question deepens our understanding of the language the planet speaks, and each small piece brings us closer to knowing whether the ghosts of the deep past are real or imagined. If we are to look for those ghosts in the record, we have to understand the ways the Earth hides them. It is not enough to imagine them buried. We have to imagine them erased and rewritten, their traces folded into the planet so completely that they become part of its natural features. This is where geology becomes both ally and adversary. On one hand, it keeps a record in stone, preserving events that happened hundreds of millions of years ago. On the other, it is constantly overwriting itself, removing details, smoothing away edges, replacing the sharp imprint of an event with a blurred, almost unreadable shadow. The most dramatic examples of this rewriting come from plate tectonics. The continents are not fixed. They drift over the surface of the planet on massive slabs of crust that move slowly but relentlessly. Where they collide, mountains rise. Where they separate, oceans form. In some places, one plate slides beneath another, dragging the surface down into the mantle where it melts and is recycled into new rock. This process has erased most of the planet's oldest surfaces. The ground beneath our feet is, in geological terms, young, even in the most stable regions. That means the deeper in time we look, the fewer surviving pages there are in the Earth's archive. Volcanism is another eraser. Eruptions can bury vast areas under lava and ash, sealing what was there before beneath a layer of rock. Over millions of years, that rock may be altered by heat and pressure, until its original form is impossible to recover. Even in cases where ash preserves fossils or artifacts for a time, erosion and tectonic activity can eventually scatter them. Floods, landslides, and glaciation can do similar work on shorter timescales, sweeping across landscapes and removing everything that stood in their path. This constant transformation means that for a signal to survive deep time, it must be either so subtle that it escapes erasure, or so widespread that no single event can remove it entirely. A thin layer of unusual metal concentration spread across the entire globe, for example, is difficult to erase. Even if tectonics swallows part of it, other sections may remain elsewhere. This is why the iridium layer left by the asteroid impact that ended the dinosaurs is still detectable today. Not because it was immune to geological change, but because it was deposited everywhere at once. If an earlier civilization left behind a similar global signature, it might also survive. But what could create such a mark? Large-scale burning of fuels could do it, changing atmospheric chemistry in ways that leave measurable traces in sediments worldwide. The mass extraction and redistribution of metals could do it too, scattering their residues far beyond the sites of original use. Even the production of synthetic compounds might work if some fraction of them reached the deep ocean and were locked into layers of sediment beyond the reach of normal erosion. Yet even if such a signature exists, finding it is not simple. We would have to know where to look, and our coverage of the Earth's geological record is far from complete. Much of the ocean floor remains unmapped in detail. Many continental interiors have never been drilled deep enough to reach the layers that might hold answers. And even in well-studied areas, interpretation is tricky. A spike in a particular metal could point to industrial activity or to a massive volcanic eruption. A sudden change in carbon isotopes might come from fuel burning or from a natural shift in ocean currents. To distinguish between these possibilities requires context, and context is often what deep time has taken away. This is why scientists often frame the search as an exercise in humility. We are used to thinking of ourselves as the measure of intelligence, the culmination of Earth's story. But if we accept that our own signal will one day be faint and ambiguous, then we must also accept that the same could be true for any predecessors. And if that is the case, the absence of obvious ruins or artifacts is not evidence that they never existed. It is evidence only that the Earth is very good at hiding its past. Understanding this also forces us to see our own present differently. We are living in a geological moment that will be visible in some form far into the future. The carbon we release, the metals we scatter, the compounds we synthesize, these will outlast us, even if nothing else does. They will form the page on which our chapter is written, a page that may one day be read by someone else, or not at all. The permanence we imagine in our works is an illusion. Their true endurance lies not in their structures, but in their residue. It is a strange thought, that the most enduring legacy of a civilization might be invisible to the eye, detectable only by instruments sensitive enough to measure the chemistry of stone. And yet, it is this invisibility that offers the best hope of survival. Towers fall, roads crack, books crumble, but molecules can persist. Ratios of isotopes can remain fixed for millions of years. Patterns in sediments can survive long after their cause has been forgotten. These are the quiet footprints that time does not always erase. Still, there is a certain melancholy in knowing that if we are found, it will be as a shadow in the data, a deviation from the norm, with no clear explanation unless the finder already suspects what to look for. And perhaps that is the same melancholy that accompanies the search for what came before, the awareness that even if they existed, their story might be reduced to the same kind of whisper. It is this whisper that draws us on. Every core drilled from the ocean floor, every analysis of ancient rock, every unexpected anomaly is a chance, however small, to hear something more. Maybe it will be a false lead, a natural event mistaken for something else. Maybe it will be nothing at all. But maybe, just once, it will be the remnant of a world we never knew. A world erased by time, but not entirely forgotten. Until that moment, we keep asking the question, not because we expect a clear answer, but because the question itself is a reminder that we are part of something larger, a history not just of species, but of possibilities. A history where intelligence may have risen more than once, where the Earth's archives may still hold chapters older than our imagination, written in a language we are only beginning to understand. When we picture the past, we tend to imagine it as a single, continuous chain, leading directly to us. A sequence of causes and effects that could not have unfolded any other way. But deep time does not work in straight lines. It works in branches, in false starts, in entire stories that vanish without leaving enough behind for us to know they were ever told. Evolution itself is full of these hidden narratives. For every species that survived to shape the world, countless others appeared, thrived for a time, and then disappeared so completely that their bones, their traces, and their very existence are gone from our reach. If this is true for life in general, then it could also be true for intelligence. We have no reason to think that the ability to build and alter the environment in complex ways can only evolve once. Life has been experimenting for billions of years, producing creatures with senses we do not have, capabilities we cannot match, and adaptations we can barely imagine. It has built armor from living tissue, eyes that see in darkness, wings that cross oceans, and bodies that survive in boiling water or in rock miles beneath the surface. intelligence in this grand experiment is only one more possibility, one that could arise more than once under the right conditions. We know that intelligence does not have to look like us. Among living species, crows and parrots solve problems and use tools. Octopuses manipulate objects and learn from experience. Dolphins communicate and pass knowledge across generations. None of these creatures build cities or uses fire, but their minds work in ways that show planning, memory, and adaptation. Scale this up over millions of years, and it is not hard to imagine forms of intelligence that leave behind no architecture, no metallurgy, and yet still shape their world in ways we might never detect. This is why the idea of an earlier civilization is not bound to the image of a city. A civilization could be something entirely different from our own, spread across oceans rather than land, existing in ecosystems we do not now have, operating on principles we would not recognize as technology. If their tools were organic or their infrastructure tied to living systems, time could erase them without a trace. Coral reefs, after all, are vast and intricate structures built by tiny creatures over thousands of years, and yet we think of them as natural formations. What else might once have been built that we now see only as geology or biology? Even if a civilization did rely on physical construction, its works might not survive in recognizable form. Consider the way ancient human artifacts degrade. Iron rusts, copper corrodes, and even stone carvings lose their sharp edges under wind and rain. Without constant maintenance, nature reclaims everything. In our own time, abandoned towns vanish into forests within decades. Given centuries, the walls fall and the roads crack. Given millennia, the very ground shifts, swallowing the last of the ruins. If the span between us and a hypothetical earlier civilization is tens of millions of years, then any direct structures they left behind would almost certainly be gone. What we would find instead, if anything, are indirect clues, disturbances in the natural cycles of the planet, a sudden change in the composition of the atmosphere, a layer in the rock containing materials not formed by natural processes, concentrations of metals or isotopes that hint at mining, industry, or large-scale energy use. The difficulty is that the Earth's own processes can create many of the same signals. Volcanic activity can produce metal-rich layers. Meteor impacts can scatter exotic minerals. Changes in ocean chemistry can alter carbon isotopes. Distinguishing between an artificial and a natural cause requires more than one signal. It requires a pattern that matches what we know from our own impact on the planet, but at a different point in time. This is why the search is slow and methodical. It involves collecting samples from many locations, comparing data across continents and oceans, and ruling out every plausible natural explanation before even considering an artificial one. And even then, certainty may be out of reach. The further back in time we look, the fewer details survive. A layer in the rock may tell us something happened, but not exactly what. Without direct artifacts, interpretation becomes a matter of probability and inference. Yet even this uncertainty has value. It forces us to think differently about our place in the world. It reminds us that the line between natural and artificial is not always as clear as we think. It encourages us to look more closely at anomalies instead of dismissing them outright. And it teaches us to see our own civilization not as a permanent fixture, but as a brief event in the planet's much longer story. That longer story is full of transformations. Continents drift and collide. Climates swing between extremes. Ice ages come and go. Seas rise and fall. life expands into new forms and then contracts again. Each cycle reshapes the stage for whatever comes next. In that context, it is easy to see how something could rise, leave a mark, and then vanish without a trace. The planet would not notice the loss. It would continue as it always has, folding the memory of what was into its deep archive, where it might remain unread until the end of time. For us, that archive is both an opportunity and a limit. It offers the chance that traces of the past, however faint, may still exist. But it also sets the boundaries of what we can hope to know. We cannot reconstruct every detail. We cannot recover what has been destroyed by heat, pressure, and time. We can only work with what survives, and what survives may be little more than a whisper in the stone. That whisper is enough to keep the question alive. It is enough to justify looking deeper, drilling further, analysing more carefully. Because if we ever do find evidence that we are not the first, it will change everything about how we see ourselves. We will know that intelligence is not a singular event, that the rise of civilizations may be part of a repeating pattern rather than a unique occurrence. And we will know that our own story is only one among many, told briefly before being absorbed into the long, slow memory of the Earth. If such a discovery were ever made, it might not begin with the dramatic unearthing of an artifact. More likely, it would start quietly. A strange reading in a lab, a spike in an unexpected isotope ratio, a sediment layer whose chemistry does not match anything else around it. At first, it would seem like an error, a quirk in the data, perhaps contamination from modern sources. Teams would check and recheck their instruments, repeat their sampling, search for natural explanations. Only after ruling out every obvious cause would the possibility emerge that what they were seeing might be something else entirely. Even then, the conclusion would not come quickly. In science, the extraordinary is never accepted without a long, cautious journey from suspicion to evidence. One anomaly would not be enough. A second sight, a third, 100 more would have to be studied, each one examined for the same signals. These findings would need to be compared across regions and continents, across land and seafloor, to see if they align in both time and pattern. The process would take years, maybe decades of careful, methodical work before anyone could begin to speak seriously of what it might mean. And still, even with such care, doubt would remain. For any signature we could attribute to an ancient civilization, there would almost always be a competing natural explanation. A spike in metals could come from large-scale mining, or from an unusually rich volcanic eruption. A sudden shift in carbon isotopes could reflect industrial fuel burning, or the collapse of a massive ecosystem after a climatic shift. Synthetic-looking compounds might have a natural origin we have not yet discovered. The challenge would not just be finding signals, but proving they could not be produced by the planet itself. This is part of what makes the search so elusive. We are trying to separate the work of intention from the work of nature, when nature itself has been shaping and reshaping the Earth for billions of years. We do not yet know all the ways it can rearrange elements, change chemistry, or alter landscapes without any trace of life's involvement. Our knowledge is always incomplete, and deep time ensures that even the clearest events are blurred at the edges. Yet this uncertainty is also the space where curiosity thrives. Each unexplained pattern in the rock record becomes a doorway, not to certainty, but to possibility. It forces us to imagine how many other patterns might exist beyond the reach of our current tools, and how many of them might tell stories we have not yet learned to read. And in imagining, we begin to understand the fragility of our own record. If we vanish tomorrow, Our cities and machines would soon follow us into absence. Within a few centuries, forests would reclaim streets, rivers would rewrite themselves, storms would batter away at the tallest towers. In 10,000 years, almost nothing of our world would remain visible. The metals and plastics we've spread across the planet would still exist, but in altered forms, rusted, eroded, fragmented into dust and silt. In a million years, those remnants would be deeply buried, transformed into something geologists might one day find without knowing they were once ours. This mirror forces us to confront the idea that the same may already have happened before. If another civilization had risen 50 or 100 million years ago, their fate in the geological record would almost certainly be the same as ours will be. Their cities gone, their machines dismantled by time, their presence reduced to chemical changes in rock and sediment. We might already have walked over their remains without recognizing them, might already have drilled through the last surviving fragment without knowing what it was. That possibility changes the way we look at the planet's landscapes. The ridges and basins of the seafloor become potential ledgers of lost events. The desert's endless dunes become locked vaults, hiding whatever the wind has buried for eons. The oldest crotons, those stubborn pieces of continental crust that have resisted recycling for billions of years, become shelves in the library of deep time, their pages worn but still legible in places. Even so, legibility is rare. The Earth is full of gaps, unconformities as geologists call them, where millions of years are simply missing. These are places where erosion stripped the surface before new layers were laid down, erasing whatever might have been recorded there. Entire chapters of the planet's history have been lost this way, and if a civilization existed during one of these missing intervals, there would be no direct trace left to find. That, perhaps, is the most haunting aspect of the search, knowing that the absence of evidence may be nothing more than the result of a page torn from the book. And yet we search anyway. We search because the act itself changes us, deepens our perspective, forces us to measure time not in decades or centuries, but in spans so vast that our entire existence feels like a momentary flash. It is in this expanded scale that we see the true nature of our relationship with the Earth. We are not its masters or its final story. We are temporary residents, passing through a planet that will outlast us by billions of years. That perspective carries a kind of humility, but also a kind of wonder. Humility in recognizing that we may not be the first to stand where we stand. Wonder in realizing that if there were others before us, we share with them a connection that crosses the deepest gulf of time. They too would have risen, left their mark, and eventually been erased, not because they failed, but because the planet's memory works on a scale too large for any single species to endure. Somewhere in a thin layer of rock on a cliff face, or in a dark seam of sediment beneath the ocean, the faintest echo of their presence might still exist. We do not yet know if we will ever find it, but the possibility is enough to keep us looking, because to look is to remember that we are part of a story still unfolding. A story written not just in human terms, but in the vast, slow language of the Earth itself. The more we think about this deep, slow language of the Earth, the more we realise how different it is from the way we humans tell stories. Our histories are short, dense and full of detail. We write them in books, carve them into stone, pass them through spoken word, each version meant to be clear to its reader or listener. The planet's version is nothing like that. It tells its story in fragments, scattered across time and space, sometimes repeating itself, sometimes skipping entire eras. Its pages are the layers of rock, the patterns in ice, the chemistry of sediments, each one a record that can be read only if we know the code. And that code is always incomplete. This incompleteness is why the search for any earlier civilization feels like chasing a shadow across a shifting surface. The moment we think we have a solid outline, part of it blurs into the background. A spike in metal concentrations turns out to match a volcanic eruption. A sudden carbon change lines up with a natural die-off. A promising anomaly loses its uniqueness when we find something similar in a purely natural setting. The Earth's processes are so varied and powerful that they can mimic almost any signal we might hope to attribute to intelligence. But even with this camouflage, there are patterns that persist in the back of the mind. Patterns that make us wonder if we have overlooked something obvious simply because we never thought to connect it. This is where the Silurian hypothesis forces us to take an uncomfortable step, to admit that our assumptions about the past are shaped as much by what we expect to see as by what is actually there. If we expect intelligence to look like cities and machines, we may fail to recognize it when it looks like something else entirely. And what might something else mean? Perhaps a civilization based in the oceans, never needing to build on land. Their structures could have been living organisms, cultivated and shaped over centuries, dissolving back into the water when abandoned. Or perhaps they were spread thinly across the planet, linked not by physical infrastructure, but by a shared biological or chemical network. If their tools were grown rather than forged, if their energy sources left no distinctive chemical scars, then even their rise and fall might leave little more than faint disturbances in the natural cycles. There is also the possibility that their footprint was small by design. Our own species is a paradox, capable of shaping landscapes on a global scale, but also capable of imagining sustainability, of minimizing impact. If another civilization reached such a balance early, they might have lived for hundreds of thousands of years without leaving the kind of concentrated, sudden signals we expect. Their disappearance might have been as gentle as their presence, leaving the geological record undisturbed except for subtle changes detectable only with tools we have yet to invent. But even a careful civilization could be caught in events beyond its control. Asteroid impacts, supervolcanoes, abrupt climate shifts. These have erased life on massive scales before, and they will again. If such an event ended an earlier intelligent species, the destruction might blend their traces into the debris of the catastrophe. The result would be a layer in the rock filled with chaotic mixtures, volcanic ash, impact ejecta, altered isotopes, all layered together in a way that hides the original cause. To separate their fingerprints from the disaster would require not just advanced science, but also the insight to suspect they were there in the first place. This is the subtle trap of deep time. It hides not only what was once present, but also the very idea that something could be missing. Without a reason to look, we may walk past the evidence without seeing it. Even now, much of the Earth remains unsampled in any meaningful way. Vast regions of the ocean floor have never been drilled. The deepest ice layers remain untouched. Deserts conceal layers that have not been studied simply because the cost and difficulty are too high. Each of these places could hold pieces of a story we have not yet imagined. And perhaps that is the most valuable outcome of this search, not the proof itself, but the widening of our imagination. The act of considering an earlier civilization forces us to think beyond the narrow slice of time we occupy, to see ourselves not as inevitable, but as one possibility among many. It also teaches us to read the planet's record with more humility, to recognize that what we see now is not the whole picture, but only what survives. For all our technological reach, we remain new to this kind of reading. The earliest attempts to understand Earth's history date back only a few centuries. Before that, the very idea that the planet had a deep past was controversial. Now we can measure isotope ratios in rocks billions of years old, detect chemical traces in ice cores, and map the seabed in 3 dimensions. These tools would have been unimaginable not long ago, and yet they are still crude compared to what might come next. If our knowledge has expanded so quickly, then the tools of the future may reveal patterns we cannot yet perceive, patterns that could make today's uncertainties suddenly clear. That is why the question remains open, not because we lack curiosity, but because the scale of the search demands patience. The Earth does not reveal its stories easily. It requires us to take fragments from many different sources, a shard of rock here, a sediment core there, and weave them together without ever seeing the full picture. Somewhere among those fragments might be a clue so small we do not yet know it matters. And so we keep looking, not just for proof of what came before, but for a better understanding of what is possible. In doing so, we also prepare for the day when someone else might search for us. When the time comes, they will read our page in the Earth's archive just as imperfectly as we read the past, seeing the spikes of carbon, the scattered metals, the synthetic molecules, and wondering, as we do now, what kind of beings left them behind, and whether they were alone. If someone were to read our page in that distant future, they might imagine us very differently from the way we see ourselves. They would not have our photographs, our languages, our music, or our names. Instead, they would have data points, concentrations of metals, strange polymers embedded in sediment, isotope ratios that break from the natural rhythm of the planet. From these, they might piece together a picture that is both true and incomplete. They might see us as a species defined by rapid change, one that altered the chemistry of air, water, and soil in a geological instant. They might infer that we harnessed vast amounts of energy, reshaped landscapes, and spread across every continent. And yet, without our own voices to explain ourselves, much of the meaning would be left for them to guess. Perhaps they would see the speed of our transformation as evidence of recklessness. Perhaps they would see it as ingenuity. They might imagine we were a civilization that burned brightly and briefly, unable to sustain our pace. Or they might imagine we chose to slow down, to fade into balance with the planet before vanishing. Without the full context, they would have only the marks we left behind, and they would interpret them through their own experience, just as we would interpret the signals of any civilization that came before us. This act of interpretation is not neutral. We bring to it our own biases, shaped by the way we live and what we value. When we look at the past, we are tempted to see reflections of ourselves, to imagine that if there were others, they would build, trade, explore, and think in ways we understand. But history, even our own, shows that this is not always the case. Cultures can differ in their goals, their technologies, their relationship with the environment. Over millions of years, those differences could be so great that we might not even recognize the signs of their presence. That is why the search for an earlier civilization is also a search for new ways of seeing. We must learn to imagine intelligence that is not like ours, to recognize traces that do not match our patterns. This requires not just better science, but also a willingness to challenge the assumptions that shape our questions. For example, if we expect technology to mean metals and machines, we might miss a civilization whose tools were entirely biological. If we expect energy use to mean combustion or electricity, we might overlook one that drew power from chemical gradients in the ocean or from the steady flow of planetary heat. Even within our own history, there are reminders of how easy it is to miss the unfamiliar. Many ancient human cultures left little or no trace visible today. Their tools were made of wood, fibre, or bone, materials that decay quickly. Their dwellings were temporary or built from earth, disappearing back into the ground within a few generations. If we know of them at all, it is from rare, fragile finds. A fragment of pottery, a scattering of stone tools, a burial preserved by accident, and that is after only thousands of years, not millions. So if there were others long before us, it is entirely possible that the visible, durable evidence of their existence has long since vanished. What remains would be subtle, chemical anomalies, unusual sedimentary patterns, or unexpected biological shifts. Recognizing such traces would mean asking different kinds of questions, ones that do not begin with, "Where are the ruins at Io?" but with, "What does not fit the natural pattern and why?" To look for what does not fit is to embrace uncertainty. Many anomalies will turn out to have natural causes we simply did not understand at first. But even these false leads can deepen our knowledge of the planet's processes, teaching us more about the cycles and forces that shape its surface. In this way, the search for an earlier civilization is never wasted effort. Whether or not we find them, we learn more about the Earth and about the fragility of our own place within it. That fragility is easy to forget when we measure time in human lifespans. We think in decades, perhaps in centuries. The rise and fall of empires, the span of recorded history, these feel long to us. But in geological terms, they are barely a flicker. Civilizations can change the face of the Earth quickly, but the Earth changes back in ways that erase almost all of it. The mountains grind down, the rivers shift course, the oceans cover and uncover the land. Over millions of years, the surface is renewed so many times that it becomes difficult to imagine anything lasting long enough to be found. And yet, not everything is erased. Some traces persist, locked in places where the planet's processes are slow, or where they deposit rather than destroy. Lake sediments, deep ocean clays, polar ice, these are the patient keepers of history. They do not preserve buildings or tools, but they do preserve signals, pollen grains from vanished forests, ash from distant eruptions, traces of metals and chemicals that hint at events long past. If we are lucky, they might preserve something more, something that whispers of an intelligence that came before. If such a whisper is ever found, it will change the story we tell about ourselves. We will no longer be the first. We will be part of a lineage that may be longer and more complex than we imagined. This could be a humbling realization, but also a hopeful one. It would mean that intelligence is not a fragile accident, but a recurring possibility, one that the universe might foster again and again. Until that day, we continue to read the Earth as best we can, knowing that every layer holds both answers and mysteries. Each core sample, each isotope analysis, each map of the seafloor is a step toward a deeper understanding. Whether we find the echoes of another civilization or only the vast silence of nature, the search itself is a way of connecting with the planet's deep past. It reminds us that our story is written on a page that will one day be turned, just as others have been before. In imagining this turning of pages, we begin to see our own moment as both fleeting and immense. Fleeting because in the scale of geological time, we are here for the briefest instant. Immense because in that instant, we have altered the planet in ways that will echo for millions of years. This duality is at the heart of the search for others who may have come before. It asks us to measure ourselves not just against our present, but against the entire history of the Earth. When we think about that history, we often picture it as a steady climb, life starting small and simple, then becoming more complex, eventually leading to us. But the truth is less like a ladder and more like a coastline, irregular, interrupted, shaped by forces that can erode as quickly as they build. Complexity has risen before, only to collapse. Diversity has flourished, only to vanish. Mass extinctions have reset the stage again and again. Each time, what comes next is not a predictable continuation, but a fresh improvisation. It is in these resets that the possibility of earlier civilizations hides. After a mass extinction, the fossil record shows a sudden shift in the kinds of life that dominate. But what if, in one of those intervals, the shift included the disappearance of an intelligent species? If they were gone before the next geological chapter began, their traces might be buried under the very evidence of the catastrophe itself. The asteroid that ended the age of dinosaurs left behind a layer rich in iridium and shocked quartz, a signature so strong that it defines the boundary between the Cretaceous and the Paleogene. If a civilization had existed then, its traces would have been mixed into that layer, indistinguishable from the debris of the impact. This is one reason the search is so difficult. The events that could erase a civilization are often the same events that leave the strongest geological signals. The very catastrophe that might destroy them could also overwrite the finer details of their existence. The rock record would tell us that something happened, but not exactly what, leaving us to infer the rest. An inference in deep time is always risky. It depends on interpreting clues that may have been altered, scattered, or partially erased over tens of millions of years. Yet even with these challenges, the search is not hopeless. It is built on the same patience and persistence that has allowed us to reconstruct so much of the planet's history already. We have learned to read ice cores for records of ancient climate, to use isotopes to date the age of rocks, to trace the fingerprints of supervolcanoes across continents. Each of these techniques began as an idea that seemed far-fetched, and each has revealed stories we could not have imagined before the evidence appeared. The idea of finding an earlier civilization may seem equally far-fetched now, but that is only because we have not yet found the right evidence. If we do, it will likely come from a combination of methods. A chemical anomaly in deep ocean sediments matched to a similar anomaly on land. A sudden worldwide shift in isotopes that cannot be explained by known natural processes. Microscopic particles that show patterns of manufacture rather than geology. Each alone might be ambiguous, but together they could point to something that demands explanation. To prepare for that possibility, we must keep refining our tools and expanding our reach. That means drilling deeper, sampling in more remote locations, and preserving the records we already have for future analysis with better methods. It means cataloguing every anomaly, no matter how small, and keeping an open mind about what it might mean. And it means building a culture of science that is willing to entertain unlikely possibilities without jumping to premature conclusions. There is also a philosophical dimension to this work. The search for predecessors is not just about solving a mystery, it is about understanding the nature of intelligence itself. If we find evidence of another civilization, it will raise questions about how intelligence emerges, how it interacts with its environment, and how it ends. Was their trajectory like ours, full of rapid growth and environmental impact, or was it entirely different, shaped by values and goals we can barely imagine? Did they leave behind lessons in their rise and fall that we might still be able to learn, even across the gulf of millions of years. Even if we never find them, the act of searching changes the way we think about ourselves. It reminds us that we are not the inevitable outcome of evolution, but one branch on a tree with many possible shapes. It suggests that the universe may be full of intelligent life, not because it is common in any given moment, but because over vast stretches of time, the conditions for it may arise again and again. This perspective can be unsettling. It means accepting that we are temporary, that our works will not last forever, and that the planet will continue without us. But it can also be freeing. It places us within a much larger story, one that began long before we arrived and will continue long after we are gone. In that story, our role is not to be the final word, but to be a chapter, one that others, perhaps in the far future, may read as we try to read the chapters before us. And so, the search goes on, driven by curiosity, shaped by patience, and guided by the knowledge that every discovery, even a small one, can shift the way we see the past. Somewhere in the layers of rock, the patterns of isotopes, or the sediments of the deep ocean, there may be a page that connects us to another intelligence. Whether we find it or not, the act of looking ensures that we do not mistake the edges of our current knowledge for the edges of possibility. The edges of possibility are always farther than we think. Each generation inherits a map of the known world, both in geography and in understanding, and each generation quietly redraws it. In the past, explorers expanded coastlines, filling in the shapes of continents. Today, our explorers work at different scales, the microscopic, the planetary, the cosmic, yet their task is the same: to reveal what lies beyond the horizon of the current map. The search for an earlier civilization fits into this tradition, though its horizon is deeper, hidden not by distance, but by time itself. Time has a way of making the extraordinary seem ordinary. A volcanic eruption, an asteroid impact, a global ice age. Each of these is rare on a human scale, yet over the span of hundreds of millions of years, they become part of the planet's normal rhythm. They shape the landscapes we know without our realizing it. Standing on a quiet plain, you might not suspect that it was once the floor of a vanished sea. Looking at a gentle hillside, you might not see that it is the softened rim of an ancient crater. The Earth's ability to transform and absorb its own history is both remarkable and, for the purposes of our search, frustrating. This constant transformation means that the survival of any trace from a distant past is an exception, not the rule. Most organic materials vanish quickly. Metals corrode. Even stone can dissolve or be ground away. The rock record is a palimpsest, a surface written on, scraped clean, and written on again. Sometimes traces of earlier writing remain, faint but still visible to those who know how to look. In geology, those traces might be an unusual mineral, a pattern of layering, or a chemical signature that doesn't fit the surrounding context. The skill lies in recognizing these irregularities not as noise, but as potential signals. To do this well, scientists must be both cautious and imaginative. Cautious because every anomaly needs to be tested against natural explanations before anything else. Imaginative because natural explanations are not always obvious, and because the possibility of an artificial cause must be considered without bias. This balance is delicate. Lean too far toward caution, and you risk overlooking the extraordinary. Lean too far toward imagination, and you risk seeing patterns where none exist. The balance is made harder by the fact that much of our planet remains unexamined in detail. The deep ocean covers more than 2/3 of the Earth's surface, yet its sediments have been sampled in only a tiny fraction of locations. Polar ice holds climate records going back hundreds of thousands of years, but drilling is difficult, and much of it is untouched. Vast regions of desert, rainforest, and mountain remain geologically unmapped at fine scales. Each of these places could contain clues, but finding them requires resources, technology, and the persistence to sift through vast amounts of ordinary data in the hope of spotting the unusual. And when the unusual does appear, it often arrives quietly, a single data point that doesn't match expectations. Perhaps a sediment layer with a sudden rise in a rare isotope, or a mineral formation that shouldn't exist in that environment. These are the moments when the mind turns, however briefly, to the possibility of something more. But the discipline of the search requires that these moments be followed by long stretches of work. Repeating measurements, ruling out contamination, comparing with other sites. Most anomalies eventually yield to natural explanations. A few remain unresolved. Fewer still deepen in mystery the more they are studied. It is in those few that the hope of discovery lies. Even without certainty, a cluster of unexplained patterns can point the way to new insights. They might not confirm the existence of an earlier civilization, but they could reveal unknown aspects of Earth's history. Sudden climate shifts, unusual geological processes, or ancient biological events. And each such discovery widens the field of possibility, reminding us that the planet's past is more varied than we imagine. There is another reason to pursue this search. It changes how we see our own future. By studying how traces survive, or fail to survive, over millions of years, we learn what might remain of us. We begin to understand which of our signals will be most visible in the far future. Altered isotope ratios from burning fossil fuels, synthetic molecules that do not occur in nature, concentrations of metals spread across the globe. These will likely outlast our monuments, our art, even the shapes of our cities. They will be the clues another intelligence would read to infer our presence. And when we imagine them reading those clues, we are brought back to the present with a sharper sense of responsibility. If we are to be remembered, even in fragments, what do we want those fragments to say? That we were careless, leaving behind a scar of pollution and collapse, or that we learned to live within our means, shaping our mark on the planet into something that might be understood as balance rather than exploitation? These are not questions the rock record can answer for us. They are choices we make now, knowing that time will judge by what endures. This is where the search for the past and the shaping of the future meet. In both, we work with incomplete information, trying to build a coherent picture from scattered traces. In both, we confront the limits of what we can know. And in both, we are guided by a mix of evidence, inference, and imagination. Whether we are looking backward to find those who came before, or forward to consider those who might come after, we are part of a chain of curiosity that may be as old as intelligence itself. Perhaps that is the most enduring connection of all, not the physical traces we leave, but the shared impulse to seek, to wonder, to imagine what lies beyond the known. If others have walked this planet before us, they may have asked the same questions we do now, gazing at the stars or into the depths, wondering if they were alone. And if others come after us, they may stand in the same place, turning over stones or drilling into the seabed, searching for our echo in the long memory of the earth. To think of that echo is to acknowledge a truth we rarely face. Almost nothing of us will survive in a form that can speak for itself. Words on paper will turn to dust. Digital files will dissolve into meaningless arrangements of bits when their storage media decay. Even our monuments, those we imagine as lasting, will eventually fall to erosion, earthquakes, and the slow, patient pressure of roots and frost. What will remain will be what the planet itself chooses to keep, what is buried, preserved, or transformed into something new. In that sense, the Earth is not only the stage for our story, but also its final editor. This is why the record we hope to read from the deep past is so fragmented. The same forces that will erase us have already erased countless others. Every layer of rock is a compromise between what once existed and what has survived the endless churn of geological time. A coastline may carry the memory of an ancient forest in the form of coal beds. A desert may hide fossils beneath dunes that have shifted for millennia. The seafloor may preserve the chemical signature of a vanished climate locked in sediments that have never been touched by sunlight. These preserved fragments are not evenly distributed. Some environments are far better at keeping records than others. Deep ocean clays accumulate slowly and remain undisturbed for millions of years. Lake sediments can trap annual layers like pages in a diary, each holding pollen, ash, and traces of chemistry from its time. Permafrost and polar ice can seal away entire worlds, holding air bubbles that carry the breath of vanished atmospheres. But these archives are incomplete, and they too are vulnerable. A shift in currents, a change in climate, or the grinding movement of glaciers can destroy what has been stored for ages in a matter of decades. And so, if an earlier civilization ever existed, the odds of finding it depend not only on whether it left a trace, but also on whether that trace happened to fall into one of these rare protective environments. Even then, survival is not guaranteed. Over millions of years, tectonic forces can bury sediments deep enough to alter their chemistry beyond recognition. Mountain building can lift ancient seafloors into the sky, where wind and rain wear them away, grain by grain. Entire chapters of the Earth's history have been recycled into magma and returned as new rock, their former contents irretrievably gone. This cycle of preservation and loss is not random. It follows patterns shaped by the planet's structure and behaviour. Understanding these patterns is part of the science of stratigraphy, the study of rock layers and the sequences they form. Stratigraphers read these layers like a book, using clues in texture, composition, and fossils to reconstruct the conditions under which they formed. For our search, stratigraphy is both a guide and a warning. It tells us where to look for the oldest undisturbed sediments, but it also reminds us how much has been lost. In the face of so much loss, it might seem futile to search for the faint possibility of an earlier civilization. But this is precisely what makes the search meaningful. It forces us to confront the vastness of time and the fragility of any trace within it. It teaches us to be humble in our conclusions, to recognize that absence of evidence is not evidence of absence, and that what we have in our hands is never the full story. There is a quiet beauty in this humility. To walk along a cliff face and run your fingers over layers of stone is to touch the compressed remains of worlds that no longer exist. Some of those worlds ended in fire, others in ice, others in slow transformation. Each layer is the residue of an age, pressed flat and stacked beneath our feet. Somewhere among them could be the thinnest of lines, a seam of altered chemistry, a scattering of unusual minerals that marks not just a change in climate or life, but the passing of a civilization. Finding such a line would not answer every question. It would raise new ones. Who were they? How did they live? What became of them? The rock would not tell us their names, their art, or their beliefs. It would tell us only that they were here. The rest we would have to imagine, filling in the outlines with possibilities shaped by our own experience. In doing so, we might see ourselves reflected, not as the centre of history, but as one of many chapters, perhaps not even the most remarkable. And this too would change us. It would expand our sense of belonging, not just to the human story, but to the planetary story. It would place us alongside others who looked at the same sun, breathed the same air, and faced the same challenges of survival. Even separated by millions of years, we would be connected by the shared fact of existing here, on this small, restless world. Until such a discovery is made, if it ever is, the search remains a kind of dialogue with the unknown. Each core sample, each geological survey, each chemical analysis is a question we pose to the Earth. Most of the answers are in the language of nature: volcanic cycles, shifting seas, ancient ecosystems. But the possibility that one answer might someday come back in the language of intelligence keeps the dialogue alive. The patience this requires is extraordinary. A single project can take decades, and its results may be ambiguous at best. Funding and attention often flow towards questions with clearer outcomes, leaving the deeper, slower mysteries to those willing to work on the margins. But those margins are where some of the most profound discoveries have been made. It is here in the slow accumulation of evidence and the careful interpretation of anomalies that the first hints of something unexpected are most likely to emerge. And so the work continues, not in grand revelations, but in small steps. A new drilling expedition gathers sediments from the far side of the world. A reanalysis of old samples reveals a pattern missed before. A student notices an outlier in a dataset and decides to investigate. These are the moments that, when strung together over years, create the possibility of an answer. And if that answer turns out to be the echo of another civilization, it will not come as a sudden thunderclap, but as the quiet accumulation of clues until the pattern can no longer be ignored. If that pattern were to emerge, it would likely begin with something deceptively small. A cluster of unusual isotopes, perhaps, scattered across multiple continents in layers of the same age. At first, the anomalies might be written off as contamination or a local quirk of geology, but then another team on the far side of the planet would find the same signature in sediments of the same period. Slowly, a web of coincidences would form, too many, too precise to be easily dismissed. And in the quiet rooms where data is compared and recompared, a question would take root. What, other than nature, could have made this? The first to voice such a question would tread carefully. Science is built on evidence, and extraordinary claims demand extraordinary proof. But history shows that the most transformative discoveries often begin in uncertainty, with someone daring to consider an explanation that lies outside the expected. The trick is not to leap to conclusions, but to keep the possibility alive long enough for it to be tested. In this way, the search for an earlier civilization is an exercise in both restraint and imagination. Imagine for a moment how such a discovery might unfold. The anomaly might be traced to a specific chemical, one that does not occur naturally in large quantities, or that is usually a byproduct of technological processes. The dating would confirm that it appears suddenly in sediments laid down over just a few thousand years and then disappears just as suddenly. Natural explanations would be explored. Could it be volcanic in origin, the result of a meteor impact, a rare biological process? Each hypothesis would be tested and one by one set aside. Eventually, the only explanation left would be the least expected, that the chemical was made deliberately. Even then, the work would not be over. A single line of evidence, however compelling, could still mislead. Other traces would have to be found. changes in the composition of the atmosphere, spikes in certain metals, patterns of sediment disturbance that match industrial activity. Each piece would add weight to the case, not as proof in itself, but as part of an interlocking set of clues. Only when these independent lines converged would the possibility begin to shift toward probability. By that stage, the discovery would no longer belong to a small group of researchers. It would become a question for the entire scientific community and beyond. Conferences would be filled with heated debates, journals would publish papers arguing for and against, and the public would watch with a mix of fascination and skepticism. The media would seize on the most dramatic interpretations, while those doing the work would remind everyone that the process is slow, that certainty comes only with time. And still, the deeper challenge would remain: interpreting the traces. Even if we were to agree that they came from an intelligent source, the leap from chemical residue to a picture of a civilization is enormous. We might know when they lived and something about the scale of their activity, but not who they were, what they valued, or what they looked like. For that, we would have to turn to imagination, careful, disciplined imagination, anchored in the evidence, but willing to explore its implications. We might wonder whether they struggled with the same dilemmas we face, balancing growth with sustainability, navigating the tension between cooperation and competition, coping with the limits of their resources. Did they experience periods of rapid technological advancement followed by collapse? Did they leave behind beauty, art, music, stories that vanished with them? Or were they so unlike us that our categories of thought barely apply? These questions would not have definitive answers, but they would shape the way we think about intelligence as a phenomenon, not just a human trait. The discovery would also force us to reconsider our place in time. No longer the first, we would instead be the latest in a line of civilizations, each separated by vast stretches of silence. That silence, once seen as evidence of absence, would now be filled with the possibility of others whose voices have faded. It would suggest that intelligence is not a rare accident, but something that can emerge again and again, given the right conditions, and that its survival is not guaranteed. Such a perspective could have profound effects on how we think about the future. If others have come and gone, we might see our own challenges in a new light. We might become more cautious, more aware of the fragility of what we have built, or we might be inspired to strive for longevity, to learn from the traces left behind by those who did not endure. Either way, the knowledge would ripple through our culture, reshaping our stories, our science, and our sense of identity. But perhaps the most subtle change would be in the way we look at the Earth itself. We would no longer see it solely as our home, but as a shared stage, one that has hosted many acts before ours and will host many after. The rocks beneath our feet would take on a new significance, not just as the foundation of our present, but as the layered memory of the planet. Every cliff, every core sample, every folded mountain would be a reminder that we are part of something much larger, a history measured not in centuries but in eons. And in that recognition, the search would continue. For even if we found one trace, we would wonder if there were others, further back still. The horizon would simply move, as it always does, revealing new questions beyond the ones we'd just answered. This is the nature of exploration. Each discovery expands the unknown as much as it fills it. And so the patient work of sifting through the planet's archives would go on, driven by the quiet possibility that the next layer might hold a story we have never heard before. If the next layer did hold such a story, it would not arrive in the way fiction teaches us to expect. There would be no intact cities revealed in a single excavation, no vaults filled with preserved technology, no sudden flood of artifacts that spoke in a clear, universal language. Instead, it would come as it always does in deep time, in fragments, scattered and incomplete, demanding patience before they can be made to speak. A fleck of metal trapped in ancient clay, a set of microscopic spheres formed in a way no known volcano could explain. A faint shift in the ratios of carbon isotopes, not linked to any known climate pattern. Each by itself might mean little, but together they would begin to draw an outline. That outline would grow sharper as new techniques joined the search. Advances in imaging might allow us to scan rock at resolutions far beyond what is possible today, revealing structures invisible to the naked eye. Improvements in chemical analysis could detect manufactured compounds at concentrations too faint to notice before. Machine learning might sift through vast datasets, spotting patterns that human observers would miss, patterns that connect a core sample from the Pacific with one from the Arctic, and both with a layer of dust in the heart of a desert. The more the outline took shape, the more the question would shift from whether there was an earlier civilization to what kind. And here, the challenge would deepen. The temptation would be to imagine them in our image, building with stone or metal, shaping tools in ways that resemble our own, organizing their lives in structures we recognize. But if they were separated from us by tens of millions of years, their solutions to survival might have been entirely different. They might have built in materials that have long since vanished, or in forms that blended so fully with the environment that even in their time they appeared natural. Perhaps their cities, if we can call them that, were vast living organisms, cultivated rather than constructed. Perhaps their energy sources left no atmospheric trace because they drew directly from chemical gradients or ocean currents. Perhaps their communications were not carried on radio waves, but through channels we have not yet imagined. The traces of such a civilization would be difficult to recognize, precisely because they would not match our expectations. In a way, the hardest thing about finding another intelligence might not be the discovery itself, but learning how to see without the filter of our own experience. This is why the search is as much a philosophical exercise as it is a scientific one. It forces us to ask what intelligence truly is, stripped of its human form. Is it the ability to build and alter the environment, the capacity to reflect on existence, the creation of culture? Or is it something more subtle, the long-term ability to adapt without destroying the conditions for survival? If we define it too narrowly, we may overlook it when it stands before us in a different shape. If we define it too broadly, we may see it where it does not exist. Even as we wrestle with these definitions, the Earth continues to change, adding its own edits to whatever story the deep layers might hold. Tectonic plates grind past each other, raising mountains and opening seas. Rivers shift course, cutting into older deposits and laying down new ones. Winds scour the surface, burying some traces under dunes while revealing others. And in the deep ocean, sediments fall grain by grain, sealing away the present for the curiosity of some distant future. That future might be ours if our species endures long enough to develop the patience and skill required to read the planet's history with greater clarity than we can now. Or it might belong to another intelligence entirely, one that emerges after we are gone, inheriting a world reshaped by our presence in ways we cannot yet predict. They might look for us as we look for others, reading the layers and wondering about the strange marks left by a vanished people. If they find us, they will not know our language or our myths. They will not know why we made the choices we did, or how we understood ourselves. They will know only what the rocks and sediments can tell them, that we were here, that we changed the planet, and that we disappeared. Whether they see that as a warning or an inspiration will depend on their own values, just as our interpretation of any earlier civilization would be shaped by ours. And so the search is not just about the past, it is also a mirror held up to the present. Each question we ask about those who may have come before becomes a question about ourselves. How will we be seen when the page turns? What traces will tell our story, and will they be the ones we would choose? Will we leave behind a planet richer for our presence, or one diminished by it? These questions have no final answer, but they are worth asking, because in asking them, we begin to see the long arc of our place in the world. In that arc, we are both the reader and the text, both the seeker of stories and the subject of one. Whether we find an earlier civilization or not, the act of searching connects us to the deep continuity of life on Earth, a continuity that spans not just species and epochs, but also the rise and fall of intelligences whose traces may be as delicate as a chemical shift in stone. And perhaps that is the quiet truth beneath all of this, that the most enduring legacy any civilization can leave is not its monuments or machines, but the curiosity it inspires in those who come after. The curiosity of those who come after is never born in a vacuum. It grows from the fragments they inherit, not always understanding their meaning, but feeling their weight. Even now, our own fascination with the deep past is fueled by such fragments. A fossilized leaf, its delicate veins pressed into stone, speaks of a forest that swayed in breezes we will never feel. A shard of pottery, glazed in colours that no longer have names, whispers of hands that shaped it with care. A pattern of magnetic minerals in ancient lava records the shifting of the Earth's poles, a silent testimony to forces we cannot see. When we hold these fragments, we are reminded that the line between presence and absence is thin. The people or creatures who made or experienced them are gone, yet in some way they are still here, carried forward in the material memory of the world. This is why the idea of an earlier civilization, even without direct proof, carries such power. It suggests that we, too, might leave echoes in the stone, faint but enduring, and that someone, someday, might listen. But listening across millions of years is unlike any other kind of listening. The signal is faint, the noise overwhelming, and the risk of misinterpretation ever present. A mineral anomaly might look artificial until a new natural process is discovered to explain it. A pattern in sediments might suggest deliberate shaping until erosion or shifting currents provide a better answer. The patience required to sort signal from noise is immense, and the humility to accept uncertainty is even greater. This humility does not mean surrendering to ignorance. On the contrary, it means building knowledge step by step, accepting that each step may take years, and that even after decades, the picture may still be incomplete. The geological record rewards those who persist, who return to the same sites with better tools, who revisit old data with fresh eyes. Often, the most important discoveries are not sudden revelations, but the slow accumulation of small insights, each refining the questions we know how to ask. And sometimes, the refinement of a question changes everything. A century ago, scientists did not think to look for chemical signatures of ancient industrial activity. Today, that search has a name, the technofossil record, and it is shaping how we think about our own future footprint. The concept arose from asking a simple question. If another species were to examine the rocks millions of years from now, What would they find that could not be explained by natural processes? That question now guides both our study of the present and our search for the past. The possible answers are sobering. Layers rich in synthetic materials like plastics or alloys that do not occur in nature. Sharp shifts in isotope ratios linked to the burning of fossil fuels. Traces of rare elements mined and distributed far from their natural deposits. These would be clear markers of technological activity, and they would likely persist far longer than any physical structure we build. In time, they might even outlast the memory of why we made them, leaving only the fact that we did. If we look for an earlier civilization, we must ask what their techno-fossil record might have been. Perhaps they use materials that degrade too quickly to survive in the geological record. Perhaps their energy sources left no atmospheric or chemical traces. Perhaps their technological signature lies in forms we do not yet recognize because we have no parallel for them in our own experience. This is where imagination, tempered by evidence, becomes essential. Without it, we risk searching only for ourselves in the past rather than for whoever might actually have been there. Yet even if we found nothing, the search would still matter. The discipline it demands, in observation, in skepticism, in creativity, sharpens our understanding of the Earth itself. Every unexplained pattern we investigate, even if it proves natural, teaches us something about how the planet works. And every time we expand the range of what we are willing to consider, we make it more likely that we will recognize the unexpected when it appears. The unexpected often arrives in subtle ways. A layer of fine silt in an ocean core might turn out to have an unusual distribution of trace metals. A series of ancient riverbeds might contain gravels that do not match any nearby source rock, hinting at long-vanished transport systems. A deep borehole in the Antarctic ice might reveal trapped gases that suggest a climate fluctuation unaccounted for by known cycles. Each anomaly is an invitation to look deeper, to test whether the past we think we know is as complete as we imagine. To work with such anomalies is to accept that certainty may never come. The Earth guards its oldest secrets well, and sometimes the cost of revealing them is more than we can pay. Drilling to extreme depths risks contamination of pristine environments. Excavating rare fossil beds can destroy as much as it preserves. Even studying ice cores comes with the awareness that, in a warming world, the archives are melting faster than we can read them. The search, then, is a race not just against time past, but against time present. This race is not one we can win in a final decisive way, but it is one we can choose to run with care, knowing that each step forward adds to a body of knowledge that will outlast us. And perhaps that is the quiet reward of the search, not the promise of a single great revelation, but the ongoing act of paying attention to a planet that has been speaking in stone, water, and wind for longer than we have existed. In paying attention, we also leave a record of our own listening, the cores we store, the maps we make, the databases we build. These are not just tools for our present use, but potential gifts to those who will come after. If they search for us as we search for others, they will find our questions embedded in the way we studied the world, and they may recognize in those questions the same curiosity that drives them. That continuity of curiosity, stretching across species, across civilizations, across the gaps of deep time, may be the most enduring connection the universe allows. We may never meet those who came before, or those who will come after, but in the act of wondering about them, we share something fundamental: the desire to understand, to locate ourselves in the vast and silent sweep of history. That desire to locate ourselves is what makes the search feel personal, even when it spans millions of years. We do not dig into ancient sediments only to learn about the sediments. We dig to understand how we fit into the story they tell. The possibility of an earlier civilization is, in that sense, a mirror. In imagining what they might have been, we are also imagining what we are and what we might become. This mirror can reflect us in surprising ways. If the traces we found were faint and ambiguous, they would remind us that even great achievements can vanish almost completely given enough time. If they were widespread and unmistakable, they would challenge our assumptions about the uniqueness of our age. And if they hinted at a civilization more sustainable than ours, leaving behind only minimal disruption in the geological record, they would force us to confront whether our own mark will be so gentle. We are used to thinking of permanence as power, the pyramids, the Great Wall, the roads of Rome. Yet in deep time, permanence may mean something else entirely, not the endurance of individual structures, but the capacity to live in ways that allow the planet to heal and continue its cycles long after we are gone. If another civilization achieved that, they may have left almost nothing for us to find. Their success in geological terms would be their invisibility. The irony is that our own search might miss them precisely because of that. We are trained to look for the dramatic, vast ruins, heavy industrial signatures, striking alterations of landscapes. These are the hallmarks of our own presence on the planet, and we assume they would be the hallmarks of any intelligence. But intelligence may take many forms, and not all of them leave scars. Some might work with the grain of the world, altering it in ways that blend into its natural rhythms. Such traces would be the hardest to recognize, yet they might hold the most valuable lessons for us. To even consider such possibilities requires us to loosen our grip on familiar narratives. It is tempting to imagine an earlier civilization as a lost twin of our own, driven by similar ambitions and facing similar challenges. But the reality could be stranger. They might have emerged in an environment utterly unlike ours, a greenhouse Earth with no polar ice, or a frozen world with equatorial seas locked beneath permanent ice cover. Their biology might have shaped their technology in ways we cannot predict. A species that communicates through chemical signals might build systems that leave no electromagnetic signature. One that lives its entire life underwater might never develop fire, but could master forms of pressure and current beyond our comprehension. Each of these possibilities opens a different path for the search. It suggests new kinds of evidence to look for, new environments to sample, new questions to ask, and each also underscores how little we truly know about the range of what is possible. This is perhaps the most humbling aspect of the work, the awareness that our imagination, however vast, may still be far smaller than reality. Yet imagination has its own power. It keeps us from settling too quickly into easy answers. It drives us to test boundaries, to explore beyond what seems likely, and sometimes it is the unlikely that turns out to be true. In the history of science, many discoveries began as ideas dismissed as implausible, until evidence forced a change. Continental drift, deep-sea hydrothermal vents, the asteroid impact that ended the age of dinosaurs. All were once considered speculative. The same may someday be said of the search for earlier civilizations. If that day comes, the evidence may be so subtle that it will take years for consensus to form. The first papers will be cautious, hedged with uncertainty. The findings will be replicated, challenged, and refined. The debates will spill into the public sphere, where certainty is often demanded but rarely possible in science. and through it all the fragments will remain, patient and unchanged, waiting for us to decide what they mean. Even if the decision is never unanimous, the act of wrestling with the question will have value. It will push us to learn more about our planet, to refine our tools, to think more deeply about the nature of intelligence and the fragility of its traces. It will remind us that the world we inhabit is not static but layered with histories, some of which may belong to minds we will never meet. And perhaps most importantly, it will draw our attention to the fact that we are, right now, creating the record that future beings will study. Every action we take, every city we build, every forest we cut, every chemical we release into the air or water is part of that record. The search for the past cannot help but become a reflection on the legacy we are leaving. Will our layer in the rocks speak of balance or of imbalance, of foresight or of short-sightedness, of a people who learned from the past or one who thought it had none? These are not easy questions, and they cannot be answered with data alone. They require choices about what kind of story we want to be told about us when we are gone. In this way, the search for an earlier civilization becomes more than a matter of curiosity. It becomes a quiet call to responsibility. The stones will remember us in their own way, but we can still shape what they will remember. And so the work goes on, not with the expectation of a grand revelation, but with the understanding that every step we take toward the unknown also brings us closer to knowing ourselves. Each core drilled, each anomaly studied, each hypothesis tested is a thread in the fabric of a story that stretches across deep time. Whether we are its first or only chapter is uncertain. What is certain is that we are part of it, and that alone makes the search worth continuing. The closing arc of any search is never truly an end. It is only the point where the questions change shape. In the search for an earlier civilization, that point may come when we realize that what we have been looking for is not just evidence, but perspective. The fragments we seek in the rock are mirrors, and in them we catch glimpses of ourselves, not just as we are now, but as we might be seen in the unfathomable future. There is a quiet discipline to this work. Researchers return to the same drill sites year after year, each time with slightly better equipment, each time extracting cores that reveal the planet's memory in thin cylinders of mud and sand. In the lab, those cores are sliced into intervals no thicker than a thumbnail, each one catalogued, examined under microscopes, tested for trace elements, and stored in climate-controlled archives. The process is repetitive, patient, and often uneventful. But every so often, a single slice will hold something unexpected, a chemical spike, an unusual mineral, a grain structure that hints at processes not yet understood. It is in these anomalies that the possibility lives. Most will turn out to have natural explanations, but a few will resist easy classification, lingering in the space between the known and the unknown. These stubborn traces are both a challenge and a promise. A challenge because they force us to reconsider what we think we know, and a promise because they remind us that the Earth's history is far from fully told. Sometimes the promise takes the form of connection. A trace found in one part of the world might match one found thousands of kilometers away, both dating to the same narrow slice of geological time. The patterns may be too precise to be coincidence, suggesting that something global was at work. The question then becomes not just what happened, but who, if anyone, made it happen. Could it have been a civilization whose reach extended across continents, shaping the world in ways we can barely detect? Or is it a natural pattern we have yet to recognize, one that will, once understood, tell a different but equally remarkable story. Such moments push the boundaries of collaboration. Geologists, chemists, archaeologists, and climate scientists find themselves working together, their different methods converging on the same puzzles. The search for deep-time civilizations cannot belong to any one discipline. It demands the perspectives of many. Even the most speculative leads can gain weight when they survive the scrutiny of multiple lines of evidence. But speculation is a delicate tool. Used carelessly, it can lead us into illusions. Used well, it can open doors we might never have found otherwise. The most skilled researchers know how to balance it, letting imagination suggest where to look, but always returning to the discipline of testing and retesting. This balance is what keeps the search grounded, preventing it from becoming either pure fantasy or narrow rigidity. In the public mind, such a search often takes on a different shape. Stories of lost civilizations have always held a certain allure, and the idea of one predating us by millions of years is irresistible. Myths and legends are woven into the narrative, from Atlantis to Lemuria to countless local traditions of vanished peoples. While these tales rarely align with geological realities, they remind us that the human urge to imagine deep histories is not new. Our ancestors too looked at the land around them and wondered who had walked there before. The difference now is that we have tools that can test such wonderings. Satellite imagery can reveal patterns invisible from the ground. Isotope analysis can date layers with extraordinary precision. Genetic studies can trace the movements of species, including our own, across continents and epochs. Each of these tools can confirm, refute, or complicate the stories we tell. And in doing so, they make the search richer, even when the answers are not what we hoped. And yet, hope is part of what drives the work. Not a naive hope for a dramatic revelation, but a quieter one. The hope that in looking for others, we will better understand ourselves. If we find nothing, it will tell us something about the rarity of our situation. If we find something, it will tell us about the resilience of intelligence, its ability to arise more than once in the history of a single planet. In either case, the act of searching affirms a truth that transcends the answer. That curiosity is itself a form of connection. Connection matters because it keeps us aware of our own moment in the long sweep of time. It is easy to believe that history began with us and will end with us, but the geological record says otherwise. Continents have shifted, climates have swung from ice to heat and back again. Life has diversified and collapsed in cycles beyond counting. We are part of this cycle, not apart from it. If we forget that, we risk making choices that shorten our chapter in the story. That is why the search is also a form of preparation. By thinking about how a civilization might vanish from the record, we are forced to think about how we might vanish. By considering what traces might survive, we are prompted to consider what traces we want to survive. These are not purely scientific questions. They are questions of values, of priorities, of what kind of legacy we wish to leave. Legacy is a word often used in the context of culture, art, or politics, but in geological terms, it takes on a different weight. Our legacy will be written in the rocks and sediments, in the chemistry of the atmosphere, in the rearrangement of ecosystems, in the layers of material we have moved from one part of the planet to another. Future beings, if they exist, will read these layers as we read those of the past, piecing together a story from whatever fragments endure. Whether they see us as a brief flare of activity or as a turning point in the planet's history will depend on what we do now. The search for those who may have come before us is, in the end, a rehearsal for how we will be understood when we are gone. It asks us to imagine ourselves not as the central actors, but as part of a cast that stretches far beyond the limits of our knowledge. And in that imagining, we may find a kind of humility, the kind that does not diminish us, but roots us in something larger. To see ourselves in the context of deep time is to recognize that our significance lies not in being first or last, but in being part of an ongoing story, one that the Earth has been telling long before us and will continue to tell long after. To think of ourselves as part of an ongoing story is to accept that most of it will remain unread in our lifetime. The Earth's narrative unfolds on scales so vast that our presence occupies only a page, perhaps even a single line, in its countless volumes. Yet within that line there is a density of experience, of choices and consequences that can shape the way the next chapters are written. This is where the search for earlier civilizations becomes less about what we might find and more about how the search changes us. It changes the questions we ask. When we sift through sediments for anomalies, we begin to see our own layer forming in real time. The microplastics already embedded in riverbeds, the carbon signatures etched into the atmosphere, the rearranged ecosystems visible from space. These are not abstract possibilities, they are part of our record now, and knowing this invites a deeper reflection. If someone millions of years from now were to uncover our traces, what story would they tell about us? The temptation is to imagine they would see our achievements, the art, the technology, the cities that glitter at night. But in truth, the geological record cares little for beauty or scale. What endures is chemical change, altered landscapes, the movement of materials from one place to another. A masterpiece painting might vanish without a trace, while a seam of rare metals dispersed by industry might last for eons. The Earth remembers in its own language, and we do not get to choose which of our words it keeps. In this light, the stories we wish to be told and the stories that will actually be told may differ greatly. An earlier civilization, if it existed, may have imagined itself as the centre of the world, the culmination of progress, just as we sometimes do. And yet all that may remain of them are subtle patterns, a thin band of altered minerals, an isotopic ratio that departs from the natural curve, a sudden appearance and disappearance of certain compounds. These are the sentences they left in the stone, and they are the ones we may leave as well. The challenge, then, is to make those sentences speak of balance rather than collapse. It is possible to imagine a future where our geological layer is notable, not for the violence of its changes, but for a momentary stability, a pause in the rapid swings of climate, a slowing of species loss, a deliberate reshaping of industry to work within the planet's limits. Such a future would not erase our mark, but it might transform it into something that signals adaptability and foresight rather than excess and disregard. In considering this, the search for the past becomes a quiet negotiation with the future. Each core sample, each anomaly examined, is also a reminder that we are being written into the same book we are trying to read. The awareness of being both reader and subject can be unsettling, but it can also be grounding. It connects us to a continuity that stretches beyond our individual lives and beyond the lifespan of our civilization. This continuity is not guaranteed. The fossil record shows that even the most dominant species can vanish abruptly, leaving the planet to recover in their absence. Extinction events, whether caused by asteroids, volcanic eruptions, or slower processes like climate shifts, have reset the stage many times. In each case, life eventually returned, but it returned changed, shaped by what had come before and by what had been lost. If we were to vanish, the Earth would continue, but it would carry our traces forward into the new forms that arose. Perhaps those new forms would never develop the tools to read the record. Perhaps they would, and in doing so, they would stumble across the faint markers of our presence. They might see us as a curiosity, a brief experiment in technological life, or they might see us as part of a longer tradition, inheriting from us both the opportunities and the risks of intelligence. Either way, we would have become part of their sense of history, just as an earlier civilization, if real, would become part of ours. It is worth noting that we are not the only beings who shape the Earth in lasting ways. Coral reefs, termite mounds, and beaver dams alter landscapes on scales disproportionate to the size of their builders. The difference is that these structures evolve slowly, shaped by the rhythms of ecosystems rather than by deliberate long-term planning. If we find an earlier civilization, the defining question may be whether their changes were intentional, not just in the moment, but with an awareness of their place in time. That awareness, the ability to imagine the distant future and act accordingly, might be the truest hallmark of intelligence. And so we circle back to our own moment. We have the awareness, we have the evidence of what happens when environmental limits are ignored. We have the means to alter our course. The question is whether we will choose to do so, knowing that our decisions will be read by eyes, human or otherwise, far beyond the horizon of our lives. The search for an earlier civilization, then, is not simply a matter of curiosity about the past. It is a mirror for the present and a map for the future, drawn in the faint lines of deep time. Whether or not we find others in those layers, we will have found something equally valuable, a reminder that we are not only living through history, but leaving it behind. The page we are writing now will be read someday, even if only by the Earth itself, and that is reason enough to write it with care. Every search, no matter how vast, eventually reaches a horizon. It is not the horizon of the world, but of our own capacity, the point beyond which the tools, the evidence, or the imagination can no longer carry us. Standing at that edge, the search for an earlier civilization leaves us with two companions, what we have learned and what we still do not know. The first is a scaffold, something we can build upon. The second is the space in which new questions take shape. What we've learned is that the Earth's memory is both generous and guarded. It offers clues in stone and ice, in the slow dance of isotopes, in the fossilized traces of lives lived long before ours. Yet it hides as much as it reveals, folding ancient stories deep into its crust, erasing others through the steady work of wind, water, and fire. If an earlier civilization walked here, the odds are against its record surviving in forms we would recognize. But odds are not absolutes, and in that uncertainty lies the enduring possibility that keeps the search alive. We have also learned that the search reshapes the seeker, the patience it demands, the humility it enforces, the creativity it encourages. These are not simply tools for finding the past. They are habits that can shape the future. They remind us that intelligence is not only measured by what it can build, but by what it can sustain, by its willingness to see itself as part of a larger story rather than its sole author. And so we return to the question that began this journey. If we are not the first, what does that mean? One answer is that intelligence may be less rare than we assume, arising more than once in the history of a single planet. Another is that survival over deep time may depend less on dominance and more on balance, a lesson that any earlier civilization may have learned too late, or perhaps mastered so well that they left barely a trace. Both possibilities carry weight, not only for how we see the past, but for how we imagine our own place in the future. The unknown, too, is a teacher. It reminds us that the absence of evidence is not the same as evidence of absence, that silence in the geological record can be the result of many forces, and that our current view of the Earth's history is still provisional. The gaps in our knowledge are not failures. They are invitations to look again, to listen more closely, to invent new ways of asking the same old questions. Perhaps this is the quiet truth beneath all our searching, that the value lies not only in finding an answer, but in learning how to live in the space between answers. This space is where curiosity thrives, where disciplines meet, where imagination and evidence work side by side. It is the space in which science and storytelling are not opposites but partners, each helping to make the other stronger. If one day the evidence does come, a pattern in the rock, a chemical signature too deliberate to ignore, it will not appear as a single, perfect revelation. It will arrive as a fragment, as all deep-time truths do, and we will have to work for years to understand it. When that day comes, our reaction will not be a shout of triumph, but a deeper silence, the kind that comes from realizing that the story we thought we knew has just grown older, larger, and more complex than we imagined. And if that day never comes, then we will still have gained something. We will have explored our planet more deeply, learned more about its rhythms, trained ourselves to see beyond the limits of the present moment. We will have practiced the art of thinking across spans of time so vast they make individual lifetimes seem like the blink of an eye. And in doing so, we will have placed ourselves within a context that is humbling, grounding, and strangely comforting. For in the end, whether we are alone in our chapter or part of a much older lineage, the fact remains that we are here now, able to wonder. That capacity to wonder, to reach with our minds into times and places we will never touch, may be the most extraordinary thing about us. It is what connects us to those who came before, real or imagined, and to those who may come after. It is the thread that ties our brief moment to the long fabric of the Earth's history. The search for an earlier civilization may or may not end with discovery, but it will always end with perspective. It will always return us to the simple, profound truth that we are part of something vast and ancient, a story still being written beneath our feet and above our heads. And in that awareness we may find both humility and purpose. Humility in knowing we are not the measure of all things, purpose in knowing we are still among the things that can be measured. So the search goes on, not as a race to the finish, but as a journey without a final page. Each question leads to another. Each answer opens a new horizon. And whether we look back through millions of years or forward into millions more, the constant is the same. The desire to know, to connect, to see ourselves in the mirror of time. That is what drives us into the field, into the lab, into the archives of stone. That is what keeps us listening to the deep, patient voice of the earth, knowing that it speaks in a language we are still learning. And as we listen, we leave our own voice in the record, a quiet acknowledgement to whoever may find it. We were here and we wondered.